going to do 10. You get to help me do 10.
Okay.
All right. Just want to remind you that normal force is perpendicular to the ramp. Apparently, we're applying a force parallel to the ramp, and there is kinetic friction, which is opposing the motion and going down the ramp, which is something that people will forget. Friction is always in the opposite direction of motion, and you have weight pulling down. All right? And so I'm going to define a coordinate system that makes this easy for me. So my coordinate system is going to have the normal force that way, and the force applied perpendicular, and the force of friction this way. And the only vector that I have to decompose is weight. Okay?
It doesn't give you an angle, but it's a 30, 60, 90 turn.
Yeah, a little trigonometry involved there. Good. So this is theta, right? And so the tangent of theta would normally be SOHCAHTOA, so the opposite over the adjacent, right? SOHCAHTOA, yep. So theta is equal to the negative tangent of opposite over adjacent, which is equal to 3, antitangent of 3 over 4. So 0.75 arctangent. That gives us a theta or an angle of 36.8. We'll round up 7 degrees. Yeah? Are we happy or not happy?
Just goes against kind of geometric rules I learned last year.
SOHCAHTOA?
Or just like the whole, we spent a lot of time on perfect triangle, or
It's not a perfect triangle. Well, I guess it is. It's a 3, 4, 5 triangle, but then what's the degree there on a 3, 4, 5 triangle? Do you remember what the degree is?
isn't it 30, 60, 90 was always the perfect triangles.
And then you just solve for it. Okay, thank you.
Tangent of that, unless I did something wrong, that's the angle, isn't it?
Yeah.
I will look up perfect triangles. It's been a long time since I thought about them. I just know that if I do the arctangent, that's what I get. Okay?
Jay is going to explain. Come on, Jay. You were just saying something. Say it.
Say it.
Would it be 30, 60, or would it not?
Wait, what?
Why not?
Because 3060 is x, 2x, and
Oh, that's right. So it's not 4, 5. It's not 3, 4, 5. That's why. Yeah, it's not a 3, 4, 5 triangle. 30, 60, 90 is not a 3, 4, 5. It's x, 2x something. Okay.
Thank you, Jay.
All right. Thank you. That was a good interjection. All right. So let's, it's Newton's second law, right? So we're trying to find the magnitude of the force to have it go up at a constant speed. So that means forces have to be balanced in the x direction. That means I have to figure out friction. So they're saying that the sum of the forces in the x direction is equal to mass times acceleration in the x direction, and that is 0. Yes? Okay. And how many forces do we have in the x direction? Well, our coordinate system, we've said this is the y positive direction and it's uniform motion, and this is the x positive direction and it's uniform motion again. And I have one vector that I have to decompose. So I really have 3 forces in the x direction, which is the thing I forgot last night. All right, so the 2 forces pulling down is the force of friction and the x component of the force pulling down, which is mg sine theta. Both of those are pulling down, right? Yes?
Yes.
Okay, and we've defined this as the negative direction. So I'm putting a negative sign in front of them. And the positive sign we said is the force applied, and they're both equal to 0. When you add them up, they're equal to 0. So if you rearrange algebraically, you get that the force applied is equal to friction plus mg sine theta. That means we have to figure out the force of friction, doesn't it? Quel dommage. Okay, that means we have to do it in the y direction too. So the sum of the forces in the y direction equals mass times acceleration in the y direction, and that's 0 too, thank goodness. How many forces do we have in the y direction? Well, once again, we only have two. We have the normal force and the y component of weight. And I defined this as the positive direction, so I've got normal minus mg cosine theta, because I've memorized that, never derived it again, equals 0, and normal force equals mg cosine theta. And so what is that? Well, the weight of my block is 5 kilograms times 9.8 meters per second squared times the cosine of 36.87. All right, and then my lousy calculator, 36.87 cosine times 5 times 9.8. Okay, and so I get a normal force of 39.199 newtons. We could round up to 39.2 newtons. Yay? So far, so good? Cool. That's the normal force. How do I find friction from the normal force? It's mu times the normal force, right? So they gave us kinetic friction for a moving object of 0.3. So force of friction kinetic equals I'll write it out. Mu kinetic times the normal force, and that's equal to 0.3, which is unitless, times 39.2 newtons. All right, I didn't round that up, sorry. So I think 11.76, but let's round it up. Okay, yeah, 11.76. So now I know my friction. I think I have everything to solve for it now, don't I? I should. All right, so let's put it back in here. My force is going to equal friction. That's 11.76. I need the x component of the weight. All right, so that would be, again, 5 times 9.8 times the sine of 36.87. Okay, so that gives me 29.4. Someone should check that math. Okay, we'll do it again. Yep, 29.4.
You're making videos, right?
I am making videos. Yeah, I'm making videos. I'm going to post them. All the videos from today I'm posting. All right? I don't like to post them, but you guys need them, so I'm going to do it. Plus 11.76. Plus I'm going to actually start making animations for you guys. Yeah. That's what I'll be doing over Christmas, I think. So that's 41.6 newtons is what I get. So that would be most nearly answer B. 2 thumbs up?
Will that be on the test?